Okay, so um, this is not really okay. This is an example. If I can read my pen work, of so this is a polar graph that's not a rose, and I know it's not a rose because there is no number right here, right, and it's a plus right here. So it's a little different than what I did on the other video in that I started with 0, pi over 2, pi, 3 pi over 2, and 2 pi, and then I divided by the n that was in here. For this one, we're still gonna start at 0, but we are going to use what value of sine will give me, so what angle will give me a value of sine that's 1/2. So we just think of the unit circle, and that's going to be pi over 6, okay? So I'm going to use pi over 6. And you should notice here that if we're using, so if we go back to our unit circle here at pi over 6, I'm just going to write here what the unit circle has. It has square root of 3 over 2 and 1/2, right? This is my sine value. Since my sine value is 1/2, that's easy to work with. If I use square root, I don't really want to deal with a square root of 3 over 2. That's 1.7 over, that's decimals. I don't want to have to graph a decimal. So I'm going to graph, it's easy to work with a 1/2. So the other values that give me 1/2 for sine are going to be 5 pi over 6. Oops. Forgot I don't want to forget that I also do need pi over 2. Okay, so we need pi over 2. Then 5 pi over 6. Then pi, 7 pi over 6. 3 pi over 2. 11 pi over 6. And 2 pi. So we're going to use that same pattern. What if this was, what did I do? If this was cosine, then I wouldn't be using pi over 6, I use pi over 3. If this was cosine. Okay? If you need to, you can move to the center. See better. Okay. So, I'm going to go in here and show you the workout that I'm going to do when I plug this in. Do I need to pause for a second so you can catch up? Okay. So, I'm going to plug in 0 in here. So, I'm going to have 2 minus 4 times the sine of 0. The sine of 0 is 0. So I'm going to get 2. Oh, I put those in the wrong place. So I'll just switch these. Sorry, I put the theta values in the r and the r in the, and then I didn't. So, oh well, I'll just switch those. So I'll put 2 right here. 2 minus 4 times the sine of pi over 6. So I get 2 minus 4 times the sine of 1/2. Oops, that's not right. Keep making mistakes here. Sine of pi over 6 is 1/2. So 2 minus 4 times 1/2 is going to give me 0. 2 minus 4. Sine of pi over 2. Sine of pi over 2 is 1. So I get negative 2. 2 minus 4. Sine of 5 pi over 6. Sine of 5 pi over 6 is 1/2. So I'm going to get 0. You guys see a pattern?
Yeah.
2, 0, negative 2, 0. Let's see what happens here. 2 minus 4 times with the sine of pi is also 0. So I'm going to get 2. Well, it looks like a pattern is happening. What do you think this one's going to be? 0. Let's find out. What's the sine of 7 pi over 6? Negative 1/2. So here, this is 2 plus 4. Oh, sorry, this is 4 times that. This is 2 plus 2, which is 4. The pattern didn't happen. So for a row, now a rose, the pattern happens. The rose goes, it would go 0, 2, negative 2, or it goes 2, 0, negative 2, 0, 2, 0, negative. I could keep going. Same pattern for a rose. But that's not true for something like this. It's a limousin or a lemniscate or a cardioid or something. You got to actually go through and do all of it to 2 pi, because you'll see that it does not hold the pattern. So 2 minus 4 times the sine of 3 pi over 2. The sine of 3 pi over 2 is negative 1, which gives me 6. And now it'll start to go back. Negative 1/2. Give me 4 again. Two minus 4 times 0. Give me 2 again. Okay. So I'll pause for a second so you can write this down. Is everybody? Okay, so let's go ahead and graph it. So we're going to graph these r theta points. Theta being 0, this is 0 degrees. We're going to go out 2. So out 2, that's right here. So I'm going to put a point right there. Theta's pi over 6, go to 0. So here's pi over 6. Radius of 0 is always going to be right here at the origin. It has no radius. Got to be there. So remember that from point to point, we're going counterclockwise. So we're going to go here, and we're going to come back like that. Then we're going to go to our next point. Pi over 2, angle pi over 2. Negative 2 means I'm going to go backwards. Here's pi over 2. I'm going to go back 2. So 1, 2, that's going to be right here. And then I'm going to continue on my curve counterclockwise. You're always going counterclockwise. So now we're going 5 pi over 6, which is right here. But our radius is 0, so we're going back to the origin. Like that. Now we have an angle of pi. It's right here. We're going to go out 2 radius. So that's there. Okay, and then we're going to, well, that's not very symmetric, but, you know, it's okay. Let's see if I can do a little better job here. Come on. There we go. Okay, and then we're going to go, where are we going next? 7 pi over 6, 4. So here's 7 pi over 6. We're going to go out 4. 1, 2, 3, 4. That's here. So it kind of stretches out to there. 3 pi over 2, 6. Here's 3 pi over 2. Go out 6. 1, 2, 3, 4, 5, 6. So then we're going to keep going counterclockwise. It's got to be a curve. Right, we're curving it out. No straight edges here. Polar coordinates are circular. 11 pi over 6, 4. Here. Counterclockwise. And then back to 2. And there we have our, I think this is called a limousin with an inner loop. Notice, like I said earlier, it's a sine, the sine, so it's along the y-axis, right? It's symmetric about the y. If this was cosine, we'd probably see this same picture, only over here. If this was a positive and a negative here, we'd probably see this thing flipped up over here on this side. Okay, so we have similar things that we see polar coordinates with translations and stuff. Okay. So, any questions?